Okay, scholars, now we're going to get into our model it and look at two different strategies on how to find area of other polygons. Remember, a polygon is just a multi-sided shape. So it could be any number of shapes. Poly means many. So the first thing you can do is find the area of a polygon by using addition. You can decompose, which means to cut up, the logo into two triangles and a parallelogram. Let's see what that looks like. So here's our original logo that the designer was creating. If we wanted to find the area of that, this shape really isn't defined for us. We don't have a formula or a method to be able to find the area of this shape. It doesn't have a name. It's a polygon. It's a many-sided shape. But we can actually turn it into shapes that we know and have the area formula for. So here we cut up or decomposed our shape into two triangles and a parallelogram. I know this looks like a lot, but how do you eat an elephant? One bite at a time. So we take it piece by piece and find the area of this logo. So here we have our shape. The first one we're going to find the area of is our large triangle, the blue triangle at the bottom. Remember, the formula for the area of a triangle is area equals 1/2 of the base times the height. So now let's take it piece by piece and find the area of the large triangle. My base of my triangle is going to be 6 inches because this triangle sits on 6 spaces in this grid. Okay? The height of my triangle is 3 inches. 1, 2, 3, because it is 3 units tall. So when I do the calculation, 6 times 3 is 18, and then half of 18 is 9. So I know the area of this blue triangle is 9 inches squared. So that's one piece. Now let's move into the smaller triangle, which is the pink one. Same formula, area equals half of the base times the height. So in this case, with the pink triangle, my base is 2 inches. It sits on 2 inches inside of this grid. This triangle is also 2 inches tall. So my base and height, 2 times 2 is 4. Half of 4 is 2. So now I have area for my large triangle, area for my small triangle. Now the third piece is the parallelogram, okay? And we remember from last week, the area of a parallelogram is base times height. So in all three of these cases, you have to be able to determine base and height of the shape. And that was part of our learning target last week and this week. So the base of the parallelogram is 1, 2, 3, 4 inches. The parallelogram is 2 inches tall. So here for our parallelogram, 4 times 2 is 8. So now we have all 3 pieces of our shape. So first it looked like an odd shape. I'm never going to find the area of this. But once we decompose or cut it up into shapes that we know, then take the time to find the area of each piece. Now we can use addition to find the total area. So if we write an expression for the area of the logo, we have the 9 plus the 2 plus the 8. What is the area of this logo? Absolutely, it is 19 in square inches is our unit for area because it's 2 dimensions. So 19 square inches. The next strategy that we're going to get into is subtraction. How can we use subtraction to find area? Let's take a look. So now we can use subtraction to find the area of these other polygons that we have, these shapes that are undefined, okay? So we can draw a rectangle around the logo, okay? Still turning it into something else that we know. So the rectangle was then composed of the shape of the logo and 4 right triangles. So decompose is breaking it down into shapes that we know, but being composed means that we're actually adding shapes to what we already have, okay? Let's take a look at that. Here's our logo from the designer. And then if you draw a rectangle around it, now the logo is still intact in the middle, but now we've drawn a rectangle around the shape to make it look like something that we know. We know what the area of a rectangle is. So it's still the same thing. You have to take it piece by piece to find the area. So now we're going to write a subtraction expression for the area of the logo. Okay? So here, I'm going to break this expression down for us. What does it mean? Well, here I have 6 times 5. Okay? Where do we get the 6 from? Because remember, this is the area of our entire rectangle. So the 6 came from the base at the bottom of this rectangle. 3 units here, 3 units here gives me 6 total units. The 5 is the height of my rectangle. 3 plus 2 is 5. So 30 is going to be the area of my entire shape. But the logo is not a rectangle. It's this little blue kind of odd shaped thing on the inside. So now I have to take the area of all the surrounding pieces and subtract the 2 and get my area. So let's take a look at the green rectangles at the bottom. Remember, the area of a rectangle is what? That's right. Area equals 1/2 of the base and height. And why do we use 1/2? Yes, because a triangle is half the area of a rectangle. So that's why a 1/2 is important. So here, the base of my green triangle is 3. The height of my green triangle is also 3. So if I'm finding the area of that, I'm going to say 3 times 3 is 9. Half of 9 is 4.5 or 4.5. How many green triangles do you see on the screen, scholars? Absolutely, 2. You see 2 of them. So then I have to multiply that by 2. Okay? If I come over here, same with my pink triangle. Same process, different numbers. The base of my pink triangle is 1. The height of my pink triangle is 2. 1 times 2 is 2. What's half of 2? Hold it up on the screen. Absolutely, half of 2 is 1. So remember, I don't have 1 pink triangle. I have 2. So then I have to multiply that by 2 as well. So it's still a lot of mini calculations built into this other polygon calculation. But if we break it down, it becomes 30 minus 9 minus 2. Do you think that the area is going to be the same? Yes or no? Show on the screen. All right, let's see if you're right. If you said the areas are going to be the same, you were absolutely right. Shouts out to you. So now we have 2 strategies. We can either use addition or subtraction to find the area of our other polygons. So now we're going to discuss which method speaks to you, which method helps you understand how to find the area better.